Jewelry making, it's this ancient craft, right? You think of fire, metal, all this super detailed handiwork. But what happens when you smash that artistry together with the logic of computer code? Well, that's what we're diving into today. We're going to see how technology is completely flipping the script on how jewelry gets designed, basically turning the old-school jeweler's bench into a high-tech digital workspace. All right, so here's the plan. First, we'll look at the new digital tools of the trade. Then, we're going to talk about something called parametric design. It's a total game changer. I'll walk you through a simple recipe for a ring, we'll check out the magic behind a command called sweep 1, and then see how all these digital blocks come together to build some seriously amazing stuff. Okay, so let's get into it. A new jeweler's toolkit, from the workbench to the workspace. Instead of reaching for files and saws and torches first thing in the morning, the modern jeweler, well, they're booting up their computer. That old physical workbench is literally becoming a digital workspace. But at the end of the day, the goal is exactly the same, making beautiful, wearable art.
So what are these new tools? It really comes down to this powerhouse trio of software. First, you've got Rhino 3D. Think of that as your digital clay, your canvas where the whole thing takes shape. Then there's Grasshopper. This is, well, it's wild. It's a visual programming tool that lets you build these powerful recipes or algorithms without having to be a hardcore coder. And then, the secret sauce, AlgoJewels. This is the final, absolutely crucial piece. It's a specialized toolkit made by jewelers for jewelers. And this is what it looks like. This is that AlgoJewels toolbar. It's not just some generic software. It's a whole set of specialized digital tools. And the key thing here is that it was built by jewelers for jewelers. That's so important because it bridges that gap between, centuries of craft knowledge and this crazy new technology. It just makes the whole thing feel way more intuitive and honestly, a lot more powerful.
All right, so this new toolkit, it's not just about new buttons to click, it allows for a totally different way of thinking. A huge shift. We're moving from just drawing a thing to designing a system that makes the thing. And that, right there, is called parametric design. Okay, let me break this down. In the old world, right, static modeling, imagine a client wants their ring just a tiny bit thicker or a half size bigger. A lot of the time, you'd have to basically start over, redraw the whole thing. Such a pain. But with parametric design, the jewelry isn't just a drawing, it's defined by a set of rules. So, you want to make it thicker? You just move a slider. Boom! The whole model updates in real time. It's insanely efficient, super accurate, and you can change things up endlessly. And this quote from the folks behind AlgoJewels just nails it. They say, AJ represents the future of jewelry CAD design by moving away from static modeling to parametric design. And that's the whole point. It's not just a new tool, it's a whole new philosophy. It gives designers this incredible level of creative control, even over the most technical, nitty-gritty details. All right, theory time is over. Let's actually get our hands dirty and see how this works. We're going to build a ring from scratch. And you'll see it all boils down to a super simple 4-step recipe. This is the fundamental logic, the key to making a ring with this system. Here it is, 4 steps. First, you start with a single point, right at the center of your universe, your 0, 0, 0 coordinate. Simple. Step 2, from that point, you create a circle. This circle is going to be the path, or what we call the rail, that the ring will follow. Step 3, you define another little shape, a curve. This is called the profile, and it's basically the cross-section of the ring band, like is it flat, is it rounded? And then the final step, you use one command, sweep 1, that tells the computer, hey, take that profile shape and just sweep it all the way around that circular path. And that's what creates the 3D ring. So check this out. Here's that recipe in action. This little block here is the ring sizer component. It's so cool. You literally just plug in, say, a US ring size 7, and bam, it spits out the perfect circle you need. And remember, that circle is our rail. It's the track that the shape of our ring is going to ride on. And here you can see the whole recipe laid out. It's actually pretty simple when you look at it. See that ring sizer up top? That's making our path, our rail. Right below it, the universal profile maker is creating that cross-section shape. Then, both of those pieces of information get fed into that one final component on the right, sweep 1. And that's the magic button. It takes the path and the shape, puts them together, and generates that awesome 3D ring you see on the left. Okay, let's zoom in on that final step, because it's pretty much where the magic happens. We're talking about the sweep 1 command. This thing is the absolute workhorse that takes our flat 2D instructions and turns them into a real 3D object. It's a super fundamental idea in all kinds of 3D modeling. So what is it really? All sweep 1 needs is 2 pieces of information. That's it. It needs a path to follow, that's our rail, and it needs a shape to drag along that path, that's our profile. It's kind of like putting a cookie cutter on the end of a train that's running on a circular track. By telling that shape to follow the path, it just carves out this smooth, perfect 3D surface. And that's how you go from a simple flat circle and a tiny curve to a solid, gorgeous ring.
Okay, so a simple 4-step recipe gets you a basic ring. That's cool. But what about the really complex, intricate stuff? How do we get there? Well, this is where the whole system gets really, really cool. The beauty of it is that each of these little recipes, each component, can be treated just like a building block. And the people who made AlgoJewels have the perfect way to describe this. They say your design can be understood as simply placing Lego blocks together. It's exactly that. It's like playing with digital Legos. Any piece of jewelry, I don't care how complicated it looks, can be broken down into these simple, reusable little blocks that you just click together. And this slide just shows that idea perfectly. Look at the right side. That's your collection of digital Legos, all wired up. You've got a block for the main part of the ring, the shank, and another one for the setting that holds the stone. You just plug those blocks together, and what do you get? You get that beautiful, complete engagement ring on the left. The best part is, you don't have to reinvent the wheel for every new design. You just combine these proven, perfectly designed parts. So, what happens when you really push this idea? What happens when you take it to the next level? Well, you get this. That crazy-looking web of components on the right? That's the complete recipe for that absolutely stunning, incredibly detailed ring on the left. And because it's parametric, every single part of that design, every curve, every stone, can be changed with a simple slider. It opens up this whole world of creative possibility, and it's all built from the very same fundamental ideas we just talked about.
So you see, this totally redefines what it means to be a jeweler today. You're not just a craftsperson anymore. You're a systems designer, an architect of beauty, using algorithms. Which leaves us with a pretty cool question to think about, right? If jewelry is now a digital recipe, if you have the power to write the code for any piece you can possibly imagine, what masterpiece are you going to design?